Hi students, now we are going to discuss about chemical properties of haloalkane. Chemical properties of haloalkane, alkyl halides. Alkyl halides or haloalkane. The alkyl halides and haloalkanes are more reactive class of organic compounds. Because of alkyl halide or haloalkane which contain carbon-halogen bond is a polar nature. For example, methyl chloride CH3Cl methyl chloride or CH3CH2 bond Br. Methyl chloride carbon halogen bond, that means called X means chlorine. Ethyl chloride which contain carbon then bromine bond. The carbon halogen bonds are more polar nature because of electronegativity difference between carbon halogen higher. Electronegativity difference between carbon halogens are higher. That is why carbon halogen bond is a break. The bond contains total how many electrons? 2 electrons. Both the electrons are moved towards the halogen sides. Both the electrons are moved towards the more electronegative halogen side. That's why the carbon halogen bond always exists as carbon it become partial positive charge, halogen it become partial negative charge. So alkyl halide or haloalkane which contain carbon always occurs the partial positive charge. That means called act as a electrophile. Halogen act as a nucleophile because of halogen is a more electronegative than the carbon. That's why the carbon halogen bond is a break. The bond contains total how many electrons? 2 electrons. Both electrons move towards the halogen side. That's why alkyl halide or haloalkane which contain carbon halogen bond is a break. Carbon always occurs the partial positive charge. Halogen always occurs the partial negative charge. So carbon partial positive charge, halogen it become a partial negative charge. That's why alkyl halide or haloalkane is a class of more reactive organic compounds. The more reactive organic compounds can be easily reacted with in the nucleophile. Is easily eliminated by using of eliminating reagent. It is easily reacted with reducing agent like nickel and lead metal. Is react with mechanism in presence of ether to form of Grignard reagents. It's a chemical properties of alkyl halide or haloalkanes. So in the chemical properties of alkyl halide haloalkane is follow the 4 types of chemical reactions are there. One is a nucleophilic substitution reaction. Nucleophilic substitution reaction. In the next one, elimination reaction. Then, in the Grignard reagent, that means called alkyl halide react with metal. Then last reaction, reduction. Then 4 types of reaction is undergo or involve the alkyl halides. First one, nucleophilic substitution reaction. In the nucleophilic substitution reaction takes place is a more amount of negative charged particles or negatively charged particles or molecule with 1 or more lone pair of electron. Those molecules which contain 1 or more lone pair of electron are negative charged particles all are act as a nucleophile. That nucleophile easily attack on electron division species of carbon atom to form of different kind of products are there. That product known as substitution product, the reaction known as nucleophilic substitution reaction. Another one, elimination reaction. Is depend upon attacking reagent, is depend upon what incoming agents. In then some of the haloalkane can be converted to alkene undergo dehydrohalogenation. What is the meaning of dehydrohalogenation? D means removal. Hydro means hydrogen. Halogen means halogen. Hydrogen halide is eliminated in adjacent carbon-carbon bond. It is eliminated to form of eliminated product known as a elimination reaction. The elimination reaction also is classified in 2 types. One is a E1 and one is a E2. Substitution reaction also classified in 2 types. One is a SN1 and another is a SN2. SN1 stands for unimolecular nucleophilic substitution reaction. SN2 stands for bimolecular nucleophilic substitution reaction. E1 stands for unimolecular elimination. E2 stands for bimolecular elimination. Is depend upon kinetics. It's the order of the reactions. Next one, react with metal. Alkyl halide react with magnesium metal to form of alkyl magnesium halide is a Grignard reagent. The Grignard reagent, otherwise called synthetic reagent, it is used to make the number of other organic compounds is with metals. Next one, reduction. In the alkyl halide reduced with nickel or platinum or palladium or lithium aluminum hydride, it can be changes into or hydrogen in presence of a hydroiodic acid, it can be changes into alkane. In these all chemical reactions is easily undergoing in alkyl halides. In the first one, nucleophilic substitution reaction. Totally how many nucleophiles are there? Two types of nucleophiles are there. One is negatively charged nucleophile, another one is a neutral charged nucleophile. Negatively charged nucleophile, all negatively charged particles, for example, Cn minus is a nucleophile, OH minus as a nucleophile, SH minus as a nucleophile, in then OR as a nucleophile, then neutral nucleophile, NH3, nitrogen possesses 1 pair of electron, H2O, oxygen possesses 1 pair of electron, hydrogen chloride, chlorine contains 1 pair of electron. So nitrogen family, oxygen family, halogen elements are halogen family, all compounds are act as a neutral nucleophile. Another one, the negative charged particles, all elements or group of elements act as a negatively charged or charged nucleophiles. So two types of nucleophilic reagents are there. One is a negatively charged nucleophile, another one in the neutral charged nucleophile. Negatively charged nucleophile which contain negatively charged species, neutral nucleophile which contain those molecules which contain one or more lone pair of electrons. Okay. In the neutral nucleophile and the negative charged nucleophile is easily substituted in the place of halogen in alkyl halide to form of product known as a nucleophilic substitution product. In first reaction, in the alkyl halide react with in the what? Potassium hydroxide, aqueous solution of potassium hydroxide. Alkyl halide react with the aqueous solution of potassium hydroxide. For example, ethyl bromide CH3CH2Br, ethyl bromide is a react with the aqueous solution of potassium hydroxide. The potassium hydroxide dissociated K plus and OH minus N. OH minus N as a nucleophile. The nucleophile substitute in the place of bromine in ethyl bromide. So CH3, CH2, OH plus KBr mode. Potassium bromide is a mode. So bromine is replaced by OH group. OH group acts as a nucleophile, bromine as a leaving group. So in the bromine is replaced by or relieved by using of a OH minus N to form of ethyl alcohol. In this reaction, example of nucleophilic substitution reactions. Another one, in the moist silver oxide Ag2O. What is the meaning of moist silver oxide? Silver oxide Ag2O suspended in water to form of silver hydroxide AgOH. Silver hydroxide. So moist silver oxide is nothing but that means called what is a silver hydroxide. So silver hydroxide otherwise called moist silver oxide. Moist silver oxide means silver oxide suspended in water molecule to form of silver hydroxide. Then alkyl halide of ethyl chloride CH3CH2Cl is a react with silver hydroxide AgOH by heating or boiling. Both processes are boiled at high temperature. The silver hydroxide dissociated silver plus and OH minus ion. The OH minus ion substitute or replace the chlorine in ethyl chloride. OH minus ions of nucleophile substitute in the place of chlorine in ethyl chloride to form of ethyl alcohol. CH3, CH2, OH plus silver chloride mode. This process also is an example of nucleophilic substitution reaction. Another one, ammonolysis. What is the meaning of ammonolysis? Alkyl halide react with ammonia. Ethyl or ethyl chloride is a react with ammonia. NH3. Ethyl chloride react with ammonia. One hydrogen from the ammonia, chlorine from the ethyl chloride, HCl mode to form of ethyl amine CH3, CH2, NH2, ethyl amine. Ethyl amine further react with another modes of ethyl chloride. Hydrogen from the methylamine, chlorine from the ethyl chloride. So HCl is moved to form of CH3, CH2, NH, CH2, CH3, CH3, CH2, then NH, CH2, CH3. Diethylamine. Diethylamines are formed. The diethylamine further react with another moles of ethyl chloride. Hydrogen from the second amine, chlorine from the ethyl chloride. So HCl, again one moles of HCl move to form of in then CH3, CH2, N, CH2, CH3, on CH2, CH3. Triethylamine. 1, 2, 3. 3 ethyl groups are there. So triethylamines are formed. The triethylamine further react with one more moles of ethyl chloride. Ethyl chloride. So the triethylamine contain nitrogen possess lone pair of electron. That lone pair of electron can easily accept the chlorine to form of tetraalkyl ammonium chloride. Tetraalkyl ammonium chloride. What is the formula of tetraalkyl? CH3, CH2 4 times. 1, 2, 3, 4. So CH3, CH2 4 times. Nitrogen it become a positive charge. Cl it become a negative charge. So in this salt otherwise called quaternary ammonium salt. Quarter means 4. So quaternary ammonium salt. Tetraalkyl ammonium chloride. So ethyl chloride react with ammonia form of primer amine. It is a ethylamine primer amine. The primer amine further react with 1 moles of ethyl chloride to form a second amine. The second amine contain nitrogen possess lone pair of electron. Second amine further react with 1 moles of then ethyl chloride to form a tertiary amines. The tertiary amine again react with another 1 moles of ethyl chloride to form of quaternary ammonium salt. In this reaction involve the SN2 mechanism. SN2. Two types of nucleophilic substitution reactions are there. One is a unimolecular nucleophilic substitution, another one is a bimolecular nucleophilic substitution. The ammonolysis process of alkyl halide involved the bimolecular nucleophilic substitution. What is the meaning of nucleophilic substitution? Nucleophilic substitution, I already told to you. Nitrogen possesses lone pair of electron act as a nucleophile. Two types of nucleophiles are there. One is a negatively charged nucleophile, another one is a neutral charged nucleophile. The negatively charged nucleophile which contain negatively charged particles, neutral charged nucleophile which contain 1 or more than what? Lone pair of electron. 1 or more lone pair of electron. In the nitrogen, in ammonia contain nitrogen possesses lone pair of electron. That lone pair of electron contain an ammonia molecule act as a nucleophile. The nucleophile substitute in the place of chlorine in ethyl chloride. Chlorine in ethyl chloride. Another one, ethylamine, CH3, CH2, NH2, ethylamine. Ethylamine contain nitrogen possesses lone pair of electron, act as a nucleophile. That nucleophile substitute in the place of chlorine in ethyl chloride to form a second amine. Second amine contain nitrogen possesses lone pair of electron, act as a nucleophile. That nucleophile substitute in the place of chlorine in ethyl chloride to form of tertiary amines. The tertiary amine can combine with another moles of what? Ethyl chloride to form a quaternary ammonium salt. In this process is a preparation of mixture of primary, secondary, tertiary amines. Primary, secondary, tertiary and amines are formed. In the primary, secondary, tertiary amines can be separated by using fractional distillation. By using of fractional distillation. The process known as ammonolysis of alkyl halides. Okay. The next one, ambident nucleophile. Ambident nucleophile. Nucleophile. Ambident nucleophile. What is the meaning of ambident nucleophile? Ambident nucleophile. The nucleophile such as cyanide and nitrite ion. Cyanide, potassium cyanide, KCN, dissociate to form of K plus Cn minus. K plus and Cn minus. Potassium nitrite, KNO2, dissociate to form of K plus NO2 minus ion. The cyanide minus ion, NO2 minus ion act as a ambident. What is the meaning of ambident? The nucleophiles such as cyanide and nitrite which can attack nucleophilic center from two sides, both sides. For example, cyanide ion contain totally how many elements are there? 2 elements. Both the elements are, one is a carbon and one is a nitrogen. No. Both the elements are donate or attack on the ethyl chloride contain carbon, methylene carbon. Another one, NO2 minus ion, no, NO2 minus ion. Totally how many elements are there? 2 elements are there. In nitrite ion which contain totally 2 elements are there. One is a nitrogen, another one is a oxygen. Nitrogen, another one is a oxygen. Both elements are easily attacked on alkyl halide contain methylene carbon. Alkyl halide contain methylene carbon to form of different kind of products are there. So those compounds which contain both the elements are attacked on the alkyl group known as the ambident. Ambident. So what is the meaning of ambident? The nucleophile such as, or the group of elements such as, or negative charge particles such as cyanide, isocyanide, or thiocyanide, isothiocyanide, nitrite and nitrate. Those molecules which can attack nucleophilic center from both sides. Nucleophilic center from two sides known as ambident nucleophile. Example Cn minus, another one is NO2 minus. Okay. For example, first one, in an alkyl halide is a react with potassium cyanide KCN, potassium cyanide KCN, alkyl halide ethyl chloride CH3 CH2Cl, ethyl chloride react with potassium cyanide KCN, potassium cyanide. Potassium cyanide dissociated form of K plus and Cn minus, K plus Cn minus. The potassium cyanide compound exists as a ionic nature. Exists as a ionic nature. In ionic amount of potassium cyanide dissociated in aqueous solution to produce K plus and Cl minus ion. The Cn minus ion acts as a ambident nucleophile. The ambident nucleophile which contain totally how many elements are there? 2 elements are there. Compared to nitrogen, carbon preference to donate lone pair of electron to methylene carbon. Potassium cyanide is ionic compound. Is easily dissociated form of K plus and Cn minus ion. The Cn minus ion which contain totally how many elements are there? 2 elements are there. One is a carbon atom, another is a nitrogen atom. Compare the carbon nitrogen. Carbon preferentially donate lone pair of electron to methylene carbon. Then Cl minus removed as a C chloride ion. So to form CH3, CH2, Cn plus KCl removed. Ethyl cyanide. Propionitrile, propionitrile plus potassium chloride is removed. It is one of the example of the reaction of ambident nucleophiles. Another one, ethyl chloride CH3 CH2Cl, alkyl halide RX, alkyl halide is a react with silver cyanide AgCl, reaction with silver cyanide. Alkyl halide example ethyl chloride CH3 CH2Cl, silver cyanide AgCN. The silver cyanide is covalent nature. Silver cyanide dissociated silver plus and Cn minus ion. The Cn minus ion acts as one of the covalent compounds in the ambident nucleophile. In the ambident nucleophile of cyanide ion which contain totally how many elements are there? 2 elements are there. One is a nitrogen and one is a carbon. Compared to carbon, nitrogen preferentially donate lone pair of electron to methylene carbon to form either CH3, CH2, Nc plus silver chloride removed. This compound is otherwise called ethyl carbylamine, ethyl isocyanide. Ethyl isocyanide or ethyl carbylamine. It is an example of ambident nucleophilic reaction. So one is a potassium cyanide and one is a silver cyanides. 2 reactions are there. The next one, in the covalent and ionic compounds of nitrite, covalent ionic compounds of nitrite, alkyl halide react with potassium nitrite KNO2. Another one, alkyl halide react with silver nitrite AgNO2. KNO2 ionic compounds, AgNO2 covalent. Covalent compounds. Covalent. The potassium nitrate dissociated, for example, CH3CH2Cl react with potassium nitrite KNO2. The KNO2 dissociate K plus and NO2 minus ion. K plus and NO2 minus ions. These are potassium nitrates are ionic compounds. K plus and NO2 minus ions are there. The NO2 minus ion which contain totally how many elements are there? 2 elements are there. One is a nitrogen, another one is a oxygen. Compared to nitrogen, oxygen preferentially donate lone pair of electron to methylene carbon to form CH3 and then CH2O, N double bond O plus and then KCl mode. Alkyl, it means called ethyl nitrite. Ethyl nitrites are formed. So ethyl nitrite. Ethyl nitrite is a functional isomers with nitroethane. Next one, the alkyl halide CH3CH2Cl react with silver nitrite AgNO2. The AgNO2 colon nature. The silver nitrate dissociated to form of Ag plus and NO2 minus ion. NO2 minus ion which contain totally how many elements are there? 2 elements are there. One is a nitrogen and one is a oxygen. Compared to oxygen, nitrogen preferentially donate lone pair of electron to methylene carbon to form of CH3, CH2, NO2 plus in the silver chloride AgCl mode. Silver chloride mode. It is a ethyl nitrite. It is a nitroethane. Nitroethane. The both compounds are functional isomer. Functional isomeric compounds. Functional isomeric compounds. Because of both compounds are same molecular formula but a different functional group. One is a NO2 functional group and one is a ONO functional group. ONO were named as nitrite. NO2 were named as the nitro. In this reaction also is an example of ambident nucleophilic attack on in the halogen in alkyl halides. It is an ambident nucleophilic substitution reaction. These are process all are ambident nucleophilic substitution reaction. Next one, thiol formation. Alkyl halide is a react with sodium hydrogen sulfide. Sodium hydrogen sulfide. Alkyl halide example ethyl chloride CH3 CH2Cl ethyl chloride. The ethyl chloride react with sodium hydrogen sulfide in presence of alcohol and hydrolyzed by water H2O as a catalyst. Alcohol and water as a catalyst. In the sodium hydrogen sulfide dissociate form of Na plus and Hs minus. The Hs minus substitute in the place of chlorine in ethyl chloride to form of CH3, CH2, in then SH plus, in then NaCl removed, CH3, CH2, SH. Ethyl thiol compounds are formed. In this reaction also nucleophilic substitution reaction. In the next one, alkyl halide react with sodium or potassium hydroxide. SN2 reaction. Bimolecular nucleophilic substitution reaction. SN2. Bimolecular nucleophilic substitution reactions. They are otherwise called Williamson ether synthesis. Williamson ether synthesis method. What is the meaning of Williamson ether synthesis method? All ether preparation from the Williamson synthesis is a follow the SN2 reaction, bimolecular nucleophilic substitution reaction. For example, ethyl chloride CH3 CH2Cl react with sodium or potassium salt of haloxide, sodium ethoxide, sodium propoxide, SN2 reaction. Sodium ethoxide, sodium propoxide. Na plus and OCH2 CH3 minus as a nucleophile. O minus CH2 CH3 as a nucleophile. The nucleophile substitute in the place of chlorine to form CH3, CH2O, CH2, CH3 plus NaCl remove. NaCl remove. So diethyl ether, diethyl ether. This process can be used to preparation of both mixed ether as well as simple ether. Symmetrical ether as well as unsymmetrical ether. Both the simple ether, symmetrical ether, unsymmetrical ether, mixed ether can be prepared from the Williamson in the ether synthesis process when alkyl halide react with sodium or potassium alkoxide. These reactions follow the SN2 mechanism to form of a diethyl ether reactions. These reactions all are follow the nucleophilic substitution reaction. Next one, important reaction. SN2 mechanism. SN2 mechanism. What is the meaning of SN2? SN2 stands for bimolecular nucleophilic substitution reaction. Bimolecular nucleophilic substitution. That means called SN2. Bimolecular nucleophilic substitution reaction. SN2 stands for bimolecular nucleophilic substitution reaction. In this reaction depend upon rate of the reaction depend upon both concentration of the substrate as well as a nucleophile. Substrate means rate of the reaction depend upon both substrate and reagent. Reagent means nucleophile. Rate of the reaction depend upon both substrate as well as a nucleophile. Next one, rate, which is equal to K2, concentration of alkyl halide and base of nucleophile, OH minus M. Rate of the reaction depend upon both the concentration of alkyl halide, that means called substrate, and the reagent, that means called nucleophile, where K2 is a second order kinetics. K2 is a second order kinetics constant. It's a constant of second order kinetics. In the SN2 reactions, all are second order kinetics. Second order kinetics. But one step process, important one step process. This reaction follow the one step process. This reaction is similar to umbrella type reaction. Is similar to looks like a opening of umbrella. The umbrella turn inside out when catch the strong wind, while the nucleophiles are the leaving groups are pushed away. This mechanism always takes place in SN2 mechanisms. In SN2 mechanism, otherwise called bimolecular nucleophilic substitution reaction, rate of the reaction depend upon both the concentration of the substrate, that means called alkyl halide and the reagent nucleophile. So rate which is equal to K2 and the alkyl halide and concentration of the base nucleophile, OH minus M, where K2 is a second order then kinetics constant. It is a second order kinetics but to follow the one step process. This reaction is similar to umbrella type of configuration with the inversion of configurations. Inversion of configurations. What is the meaning of inversion of configuration? Important points. Inversion of configuration. If we take the initial compound is levorotatory. If we take the initial compound is levorotatory, L compounds. Levorotatory means then product is dextrorotatory, D substance are formed. Product is dextrorotaries are obtained. Then or if we take the initial compound, that means called reactant, dextrorotatory, it can be converted into product is a levorotatory, L forms are obtained. So L can be converted to D or D can be converted to L. Levorotatory substance can be changes into dextrorotatory substance or Dextrorotatory substance can be changed into levorotatory substance known as a inversion of configuration. That inversion of configuration first observed by Paul Walden. That's why in this configuration otherwise called a Walden configuration. Inversion of configuration of SN reaction otherwise called a Walden of configuration is similar to opening of umbrella. It looks like a opening of umbrella. When the umbrella turned inside out when catch is strong wind, while the leaving groups are pushed away. For example, methyl chloride, CH3Cl, CH3 hydrogen, carbon, hydrogen, one chlorine, methyl chloride, react with OH minus ion. The OH minus ion does not attack in front side of chlorine atom. The OH minus ion always attack on the back side of chlorine atom to form of HO or hydrogen bond or attractive forces, intermolecular force of attraction with the center carbon atom, hydrogen, then or attractive forces with the bromine atom Br. It is a transition state, intermediate state, molecular state, transition state, intermediate state, unstable state. In the unstable state of compounds can be changes into hydrogen, carbon, hydrogen, in the bond OH plus Br minus can be removed. These compounds are not article active because of center carbon surrounded by or center carbon linked with totally how many hydrogen? 4 hydrogen atoms are there. The 4 hydrogen atoms are similar atom. That's why center carbon is not a asymmetric carbon. Center carbon is not a chiral carbon. That's why the compounds are not optically active. So product also not optically active. If the reactant is optically inactive, product also optically inactive. If the reactant is optically active, product also optically active. If we take the reactant is a dextrorotatory substance, product is a levorotatory substance are formed. If we take the reactants are levorotatory substance, product can be changes into dextrorotatory substance are obtained. It is a inversion of configuration. That inversion of configuration similar to opening of umbrella. When umbrella in the turn inside out when catch the strong wind while the leaving groups are pushed away. In this configuration, inversion of configuration first observed by Walden. That is why in this configuration otherwise called Walden configuration. Next one examples are there. 2-bromo-octane. For formula of support 2-bromo-octane CH3 CH Br C6H13 2-bromo-octane. The 2-bromo-octane which contain totally how many atom or group bond with the same carbon? One methyl groups are there, one hydrogen atoms are there, or bromine atoms are there, and then one alkyl group C6H13 alkyl groups are there. So 4 different atom or group bond with the same carbon. That carbon asymmetric carbon. That compounds are optically active compounds. That compound can be represented by carbon, and then CH3, and then hydrogen atom far away from the I can be represented by this way. Another one, in the alkyl groups are present towards the I. In this alkyl group can be represented by that way, C6H13. In the carbon bonded with the bromine Br, 2-bromo-octane. The 2-bromo-octane react with the nucleophile OH minus ion, sodium hydroxide or potassium hydroxide. OH minus ion. That OH minus ion does not attack front side of the bromine atom because of OH minus ion is a small size, bromine atoms are large size. That's why the OH minus ion do not attack on the front side of bromine atom. The OH minus ion attack on back side of or opposite side of the bromine atom to form of intermediate stage HO partially bonded with the carbon atom, CH3 ether bond hydrogen atom, or covalent bond with the alkyl group. C6H13, then partially bonded with the bromine atom Br. These are state known as transition state or intermediate state or molecular state or unstable. This intermediate is unstable. In the intermediate again further can be converted into CH3 bond C, and then bonded with hydrogen atom, and then another one bonded with alkyl group of C6H13 bonded with OH group. It is a 2-hydroxy octane or 2-octanol octanol. It is a 2-bromo-octane. 2-bromo-octane can be converted to 2-octanol. It is a transition state. Is a negative charge. That means called what? Levorotatory substance. The levorotatory substance can be changes into dextrorotatory. Dextrorotatory can be indicated by positive sign. Levorotatory can be indicated by negative sign. If we take the initial compound is a levorotatory, product dextrorotatory substance. If we take the initial compound is a dextrorotatory, product is a levorotatory substance obtained. So inversion of configurated substances are obtained. In this configuration first observed by Walden. That's why the configuration otherwise called a Walden configuration. It is a transition state or intermediate state or molecular state or in the unstable state. In transition state, in the center carbon not completely bonded with the OH group, not completely relieved from the Br minus ion. OH group partially bonded with the carbon atom, Br minus ion also partially bonded with the carbon atoms. Okay students? Today topic over. The next topic we will meet the next video. Thank you.